Hi there, Paul here from the engineeringmindset.com. In this video we're going to look at the basic operation of a centralized chilled water system. Now this is very typical in office buildings all around the world, and we've got a little model here of a basic office building stripped of all its insides. And if you can imagine, normally these floors would be filled with people and computers and server rooms, and it's going to generate a lot of heat, especially when the sun is beating down on the building in the middle of summer. So this building is going to have to produce a lot of cooling to handle that heat and keep the inside of the building at a very nice temperature. So how does it do that? Well, you need some plant items first, and in this very typical setup we've got a chiller here along with the distribution pumps, the air handling units, and the cooling tower, which is up on the roof. So the chiller is the producer of chilled water in this system, and the chiller has two main cylinders. One is the evaporator here, and that's where the chilled or cold water is produced, and the other cylinder is this at the back here, which is the condenser, condenser cylinder, and that is where the heat of the building is collected and sent to the cooling towers. Now a real chiller will look something like this, with the evaporator, the chilled side, which is in this case all insulated to keep that cool for the inside, and then you've got the compressor on top, as well as the power supply and the controls for the system as well. This is a centrifugal chiller. There's lots of different types, which we won't go into detail in this video. We just need to understand the basics of how this building is cooled. So the chilled water leaves the evaporator and is pulled out, in this instance, by the pump. Sometimes it can be pushed in this case it's being pulled out. It's dependent on the system and the design of the chiller. And you'll notice that I've coloured these pipes in. One is a dark blue, that's for leaving the evaporator, and I've put it at dark blue so that you know that it is a much cooler temperature. So this is leaving at about 8 degrees, maybe 6 to 8 degrees, and is leaving in this design at 54 litres per second. The other pipe, the lighter blue one, that is so you know it is a higher temperature, and in this instance it's about 14 degrees Celsius. 12 to 14, maybe a little bit higher, maybe a little lower. It all depends on the design of the system and the load of the building. In the real world though, these pipes will not be this colour. They could be, but they're unlikely to be. In the real world they will look something like this, and you can see here we've got chilled CHW, chilled water flow, and an arrow so you obviously understand where it's going, and chilled water return with the British standard colour bands and arrows and labelling system there. And this is in almost every plant room you'll find the pipes will be labelled and noted this way. But for illustration purposes I've just coloured them in here so you get a better understanding of what is happening in the system. So the pump is pulling this chilled water at about 8 degrees, and it is sending it up into the riser. A real live pump looks something like this. This is the direct coupled centrifugal pump with the motor on the back here, and then it's coupled straight onto the pump here, which is under some insulation, so you can't see it unfortunately in this photo. But that chilled water is sent up into the riser, which are these pipes here, and that riser, or those risers, rise the height of the building, and branching off of the risers are some feeds, flow and return, into these, which are air handling units. In the real world, the air handling units will probably look something like this. This is a very small example. There are much larger designs and even smaller units than this as well, but it all depends on the design and the load of the building. Here we've got the flow and return, and it's going into the coil here, which I'm going to explain about just shortly. And we've got one coil here for heating and one for cooling as well, which I'll talk about next. So the air handling unit, its purpose is to take the warm air within the office floor. It gets pulled in through a fan, and that fan then rejects it out the other side, and it's distributed off through some ductwork off to various points in the office to where it's needed. And inside this air handling unit is a coil, and the coil will look something like this in the real world, and chilled water enters the coil and makes its way up through all these little loops here, and then back out the top here. So that enters at about 8 degrees in this example, and by the time it reaches the top there, it'll leave that cooling coil at about 14 degrees. So that rise in temperature is the result of the air which is passing through this air handling unit cooling down. So the warm air enters, it hits this coil, the coil transfers its cool into the air, and the air transfers its heat into the coil. The air leaves at a lower temperature, and the water then leaves at a higher temperature. The air handling units, there could be one per floor, there could be multiple per floor, there could be one on the floor here, and the ductwork serves a number of floors below. This is just illustration purposes to just to help you understand that. So that chilled return water goes back into a riser, and that is fed back down into the evaporator of the chiller. Inside the chiller is a separate system which is running around between the compressor, the condenser and the evaporator, as well as the vane guide at the bottom there, and that is a refrigeration cycle happening in there. And what's happening there is the heat within this pipe here is being carried away by the refrigerant and sent into the condenser, where it can dump its heat and be taken away to the cooling towers. Inside a chiller, it'll look something like this. So we've got the evaporator side here, the cool side, and the condenser side here, as well as the compressor and the vane guide at the bottom there. So the refrigerant is just flowing around this system here, transferring that heat from one side to the other and going to a continuous loop. We've got some other videos on the refrigeration cycle. If you want to learn more, just check out our videos. So now that the heat in this pipe here has been transferred over to the condenser side, the condenser then sends this water, which is now called the condenser water, and sends that up to the tower. And in this instance, I've coloured this pipe red so that you know it's a higher temperature, and in this example it's about 35 degrees Celsius obviously, and it's at a flow rate of about 58 litres a second as well, being sent up to the cooling towers. That can change as it's just on this design for illustration purposes. And we've got the condenser return water here, and in this example it's about 28 degrees, so it's lost by the time it goes up to the cooling tower and comes back, it's lost about 7 degrees in this instance. That's at design though. In the real world it may not be as high as that. In the winter it wouldn't, it would be much lower too. But yeah, so in the real world the condenser pipe work will look something like this. So oh sorry, that's the wrong one, that's chilled water return. It will just say condenser water here, and we'll have some markings on the colours there. I've used the wrong image, apologies. So that warm condenser water is sent up to the cooling towers on the roof of the building, and in this instance it's an open cooling tower, so that means that the warm condenser water enters into the cooling tower and is sprayed, and that spray is then runs down the inside of the cooling tower and is collected at the bottom. Running in the opposite direction is air being pulled by these fans here, and these fans pull the ambient air outside the building into the cooling tower and out up through the top. In that process, this warm condenser water will lose some of its heat, and the air entering and leaving this cooling tower, it will leave a much higher temperature than when it came in. It will also have left with some moisture, so the relative humidity will have increased as well. A real cooling tower looks something like this. This is the Baltimore Air Coil Company. This is a very typical cooling tower you'll find on the roof of lots of buildings. And just to give you an idea, if you're not familiar with cooling towers, this is New York City, and as you can see, almost every building here has cooling towers of one size or another. Some more than others, it all depends on the size of the building and what's happening inside there as well. But they are on every big building in pretty much every city around the world. So once this cooling tower has lost about 7 degrees in the cooling process, it is collected at the bottom and it is sent back down to the condenser pump, and that is then pushed back inside the condenser. I've actually put this pump around the wrong way there. That's obviously coming out there. Should be the other way, pipe the other way, but this is a free video, so I'm not correcting it. And yeah, so this is where the water, the condenser water, then comes back into here, enters into these coils inside and picks up more heat, and is sent back up to the cooling towers. It's important to note that this system here, the condenser water system and the chilled water system, are completely separated. They do not interact, they do not swap the water in between. It is just the refrigerant, which happens in the refrigeration cycle between these units. That's the only thing that passes between them. The water in here is sealed in tubes and leaves again through those pipes. Also in this instance we've got one plant item, and by plant item I mean a mechanical asset. In the real world it's unlikely you'll have just one. You'll probably have n plus 1, so n, whatever you need, you have that number plus 1, because if this item here was to break, or say this pump here was to break, then we wouldn't be able to produce cooled water or condenser water, and we wouldn't be able to cool the building down. So we'd always usually have at least 2 units there, and they'll operate in duty and standby. So only one plant item will operate at any one time, and they'll probably rotate their duties, so that this pump would run for a week and the other one would then run for the week afterwards, and swap vice versa. And that also allows you to carry out maintenance on the system as well. On larger buildings, you're more likely to have a much more complex system than this. You'll have 2, 3, 4 chillers, maybe even more than that, and a lot more air handling units and cooling towers, or bigger cooling towers. And the complexity of the system is completely based on the load of the building. You might even have a number of separate chilled water systems. You could have a system which deals with critical, so it's generator fed and it supplies only the server rooms because they need cooling 24/7, and you'll have this common centralized system which handles the space temperature within the floors. But this is a very basic overview, and we'll go into more complex systems in later videos. But thank you for watching, and please check out our others.